already know there are different ways to solve a system of equation, right? One is algebraically, another would be by, well, the two algebraic ones. One by substitution, one that's called linear combination, and of course you can solve graphically, right? But like if you're going to do it graphically, you have to be careful and be as accurate as you can, right? Like it was a good example of the last one, right? My digital stuff was off a little bit, so it was off by 1 minute and one question, right? So.
Why is it 8th grade?
I don't know. Is there a sentence that's in the middle of?
You've seen this technique in for 8th grade.
Yeah, see, that's a sentence, right?
But here we'll explore more.
Anyway, they say a lot of worthless stuff usually to open these things up.
Did you make this?
Anyway, so you know that whenever two things are equal, you can replace one another with each other, right?
Yeah.
And it's just whenever they're equal, okay? So that's what we're going to be doing, that's all. So consider the system, and here's its solution, x equals 4 and y equals 1. So in other words, 4 comma 1, right? So that 4, 1's a solution. Do we have to do that?
Yeah. No.
Okay, you just plug them in, right? I think we know how to do that. You just plug it in. I'm just going to say yes, it is, okay? We've done that a million times. What I want you to notice here, do you see this? The one equation is 2x plus y equals 9. The second one is y equals x minus 3. Okay. Do you see this y up here?
Yeah.
Okay. What does that y actually equal? So couldn't I just replace that y up there with x minus 3? Because y is equal to that? Because equal things can replace each other, right? Okay, so probably you've done it before. So there they want, that's what they want us to do. Substitute the x minus 3 in for y in the first equation, right? So let's do that. So instead of 2x plus y, it's going to be 2x plus what?
X minus 3.
X minus 3. Do I need parentheses around that? Technically, yeah, because then I multiply, distribute a 1. Definitely if you're subtracting it, right? Because then it would change it. So let's combine like terms. What do we get? 3x minus 3 equals 9. What do you notice went away, by the way, in the equation when we substituted? The y. So we can solve an equation with one variable, right? So now we'll solve it for x. So what do we do now? Right? This is, so 3x equals 12. Divide by 3. X equals 4. Hey, that's what they're telling us up there. Well, now we know that x equals 4. Can we solve for y somehow? Huh?
Yeah.
So what would I do with this 4?
You plug it into the
Which one of those two equations do I plug it into?
y or the.
It doesn't matter. This is the thing. It doesn't matter. Either one of them. Whichever one blows your hair back.
Both.
Okay. The bottom one seems like it's easier, isn't it?
Yeah.
So let me take this. Well, I want y, but so look at the bottom one. Come on.
It's so much easier.
But the point is, either one of them you can plug it in. So y equals what? Minus 3? So y equals 1. And always list it as an ordered pair when you get done doing that, okay? 4 comma 1. That's not hard, is it? Okay? Now this was nice because they already had one equation where this y equaled something, but it wouldn't be too hard to like solve it for y and then go back and plug in, yeah? So they just state the opposite. Equals may always be substituted for equals. Let's take a look at this. So y equals 2x plus 5, right? And then the other equation is y equals negative 3x minus 10. Well, I got a question for you. If this thing equals y, and that thing also equals y, what can you tell me about these two things? They equal each other. So could we just put an equal sign between them? That make sense? They equal each other, we just do that. So let's do 2x plus 5 equals negative 3x minus 10. Do you understand why I'm doing that? Because they both equal y according to what they gave us. So now I want to get all my x's on one side, everything else on the other. What do I do? Add what? 3? No. Add what?
3x.
3x.
Or minus 3x. Wait, no.
No, positive.
Can I do something at the same time?
Subtract your
Let's subtract 5 from both, so might as well do that, right? Get it out of there.
5x
5x equals negative 15, yeah? X equals negative 3. So we got that. Now I need y. Does it matter which one I plug into up there? It doesn't, does it? Well, I'll tell you what, use whatever one you want. Everyone just use whichever one you want to use. Use one of them. Take that x and put it in there or there. I'm going to do the top one. Y equals 2 times negative 3 plus 5. So,
1.
negative 1.
Negative 3.
So you write it like this, negative 3 comma negative 1 is your final answer. Any questions on that? Okay. Let's try part B here. We're using substitution to solve it. 4x minus 2y equals 16. Y equals negative 5x plus 13. Does something look real convenient there to substitute in to the other?
Yes.
Which one looks really convenient to plug into the other one?
Y equals.
Yeah, they already got it right there blatantly is y equals this stuff, right? So you see this y up here? What am I going to replace it with?
Negative 5x.
But now I'm definitely going to need what? Parentheses, right? So 4x minus 2, not y, but what it's equal to,
5x.
equals 16. Everybody with me? Now what do? I have to distribute that. What am I distributing actually? The negative 2. Don't tell me 2, right? So distribute the negative 2. So 4x what? Plus 10x minus 26 equals 16. Can we combine some like terms?
Yeah.
14x minus 26 equals 16. What now?
Add 26.
Mm-hmm. So 14x equals what?
42.
42.
Divide by 14.
What does x equal?
3.
3. So we're not done. We need to get y, don't we? Which one do we have to plug it into?
Either.
It doesn't matter. Which one looks really convenient? Yeah, let's put the x in here in the box because we got y equals, right? So y, negative 5 times our 3, negative 15 plus 13, which is what?
Negative 2.
Negative 2. So 3 comma negative 2. And so if we were to graph both of those, that's the point where they're going to intersect. Yeah? Can I get the idea here?
Yeah. I've already did this like 3 years.
Oh, good. It's a review. Let's go on to exercise 3. Hey, I got a guy named Kirk again for some reason.
Yesterday. It's always Kirk.
So we're going to have to write a couple of equations for this one, right? And it's what you remember the ones we did with the ages and stuff? Okay. So Max's father, Kirk, they know that the sum of their ages is 52. Does that give us an equation? And Kirk is 7 years older than 4 times Max's age. So let's focus on this one. You know? And they want us to use M for Kirk's age, and K, or Max's age, K for Kirk's age. So what would be our equation for that?
2.
M plus K equals 52. Yeah? Okay. Now, how about this other one here? Kirk is 7 years older than something. What's the something at 7 years older than?
4 max.
4M.
Wait,
So Kirk is,
7 plus 4M.
yeah, all right, I prefer to do 4M
2.
plus 7. How about that? 7 plus 4M, either good.
Minus.
All right? So let's solve for their ages. Well, that's part B. I'll just, whatever. We'll just kind of sprawl it out here. Read B. What should we do here, guys? Anything we can substitute?
No.
Yeah.
Oh, the 52. K equals 52.
M equals M equals.
Do you guys see a K in both equations?
Yeah.
And does one of them actually say K equals stuff?
Yeah.
So what can I do with this K?
M plus K.
I'll add it. I'm
M plus 4.
I can replace this K with what?
4M plus.
The thing it's equal to, right? 4M plus 7 can go in there. So I'll take the top equation, M plus, not K, but the thing it's equal to, 52. Well, technically, I should have parentheses around that and distribute through the positive 1, right? But it's not going to change anything. 5M, when we combine like terms. And I know you guys know what to do now, you just must. So 5M equals what? 45. No, it's not. Divide by 5, how old is Max?
He is 9.
He's 9 years old. Let's find out how old his father is. What do we do for that? Which one do you want to use? First equation, sure. So M plus, or what plus K? So 9 plus K equals 52. K equals what? 43 years.
He's old.
Yeah, that's the near death.
I know.
At 43. 51.
Really?
Yeah. Even closer to death.
Sorry.
than Kirk. That's okay. It's okay. I've lived a full, decent life. I've done everything I've set out to do. Maybe.
Dang, that got dark.
I mean.
All right, so you guys remember how to write these equations. We did this, back in the first unit, right? Okay, and now you know how to solve them by substitution.
My dad's 50.
Yeah.
My mom.
Yeah. All right, so we got 2 cell phone plans, right? They got these texting packages, which, I wonder how much this even applies. Like, does anyone have a limit on the number of texts they can send anymore? I mean, that was a thing.
He's 40.
See, that was a thing probably 15 more years ago. Where you didn't, unlimited texts was not that common. You had to pay for that, but now it's, so anyway, but now it's just a,
Wait, don't you feel off too?
Technology is overrated.
I don't know of any plan that makes you,
Unlimited talking text.
I don't know any of them that don't have unlimited talk.
I thought it was like those one phones you get from like.
There may be unlimited data, or maybe data limits. That's still the thing.
Yeah, there's
The
like
number of
3
texts.
easily.
Technology is just overrated.
I used to have a phone that was.
Other than hearing.
Anyway, so the first plan, $5 per month, and then 3 cents per text. Does that sound like a starting point in a rate of change?
$5.
Like a B and an M? Yeah? So I'm going to call Plan A, we're going to do the cost of Plan A, so C sub A. In Plan B, we'll call it C sub B for our equation, right? So there's no monthly charge. What would be the B for that? 0, right? So this 5 would be the B. Down here, B is 0. And what's the M, the rate of change there
0.3.
for the second one?
0.
Okay, so let's get an equation for the cost of Plan A. What would it be? And we use,
T equals
we'll use T for the number of minutes. Well, it's gonna be like this, mx plus b, right? But instead of x, we're gonna use T.
C sub A equals.
What's the M for plan A? 0.03
T
T, that's not, it's text, right? Yeah, so T. Plus, what's the starting point?
5.
Plus $5. Now let's do the plan for the cost for B.
Equals
Point 10
3
T,
plus 0.
I don't want to put the plus 0,
You can
right?
put point one.
I could, right, you're right. You could.
I'm putting point two again.
You put point 1.
Okay.
Okay, so what do I want to know? What do I want to know? The some number of texts T where the two plans cost the same. If they cost the same, that means that they are what? Equal. So what do we need? We need to figure out, we need to find out when cost of plan A equals cost of plan B. You see that little equation I wrote?
Yes.
Is there something that cost of A equals and cost of B equals that I can substitute in for these two things? What can I substitute in for C sub A? What's it equal to?
3
That's not a point 3.
point 03.
So this is 0.03T plus 5, and I can replace this with what?
Point 10T.
Because they're equal. So 0.03T plus 5 equals 0.10T. Right? I want to switch this around because I know what's going to happen. You know my problem, right? Does that bother anybody?
No.
Okay, let's solve this for the number of texts then. You know what to do, right? You got all the T's on one side. What do we do? Come on.
So this starts point 03.
Does that give us 0.07T equals, yeah. Now just divide both sides by what? Nope, 0.07. And what's 5 divided by 0.07, guys?
71.
71.4 texts.
I'm using a point 1 half.
Well, that's my follow-up question. So is there a number of texts
71.
where they will be equal? Will the two plans be equal at 71? If they need to get to 71.4 to be equal? No. So there isn't really enough, because texts are a discrete value, right?
Yeah.
You either send 1 or 2 or 3. Right? You don't send 2.5. Huh? That wasn't part of it. It was just per text. Okay? So there there is no full number of texts where they'll be equal. Does that make sense? 71, they'll be close. 72, they'd be really close, right? So maybe that's enough for you to make a decision. Right? Okay. We got one more here. We got a man and a woman.
Well, they got a picture.
Yeah. They're walking towards each other. They must be in love, right?
Towards love.
Yes. People walking.
Man and woman start.
True love.
Yeah. I mean, in reality, she'd probably be running the other way, but
Are you rocking?
you know what I mean. So, man and woman start 380 feet away from each other, walking a straight line towards each other. So, one of them's walking at 6 feet per second. Does that sound like an M?
Yeah.
And the other one's walking how fast?
2 feet per second.
That sounds like an M, a rate of change. When will they meet? Well, this is a little interesting, right?
When they walk faster.
Huh?
When
Let's do an equation for the woman here. For her distance. Her distance, we'll call it distance sub W for distance of woman. Is going to be equal to what? How fast is she going?
For a second.
So what is it? 6 T?
T sub W.
Yeah, distance of the woman.
Okay, D sub B.
Right, so 6 feet. So every second she gets 6 feet. How about the D sub M for D distance of the man? That'd be what? 2T, right? Okay. So we have an equation for both their distances, right? So they're each traveling some portion of how long? How far apart are they?
280 feet.
380 feet.
They're not even 3 inches apart. That's definitely bigger than 3 inches.
The book's not big enough. You ever looked at a map and wondered how you fit?
Yeah.
So their two distances, which we have equations for, have to add up to what?
380.
For them to meet, right? So that means the two of them together covered 380 feet. Their distances have to add to 380.
Oh, 8T.
Well, let's just do it this way. So I would say, let's just make a note. The sum.
You just messed everything up.
The sun.
The sum of
They're 8 inches apart.
their distances must be what?
380 feet.
So how do we write that? How do we write the sum of their distances?
8T equals.
Well, let's not get too far.
2T
Yeah.
380.
6T, watch like every time,
60.
plus 2T equals 380. You can solve that pretty easily. This isn't that hard, right?
I thought it was like.
You see how this one's a little different than the other ones we did? Right? Now we're getting the sum of things. So 8T equals 380. Divide by 8. And how long will it take them to meet? To the nearest tenth of a second. Calculate.
$47.5.
What?
Um,
Seconds. Okay? That makes sense?
I know.
That's almost a minute.
All
All right.
Not walking very fast.
All right, we've got one Regents question to look at. Let's read this one over. Think about what we know about substitution. Using the substitution method. Now we got a veto.
What's that?
Dude.
Really?
So there's our system of equations. So somewhere along the line, he used one of those things that are the choices. What do you think, knowing what you know about substitution? Does it look like something got substituted in each one of these?
Yeah.
There and there and there and there? Yeah?
Yeah.
Okay. You just need to kind of figure out what he substituted and which one is correctly done. Like in choice number 1. Choice number 1, look at it.
No, that's wrong.
How do we, okay. That looks like you got it all discombobulated, right? Because this kind of looks like the second equation, but that's an X, should be a Y, right? Something's not right there, everybody agree? Okay, what about the third one? Let's just go down to number 3. Which equation does number 3 look like, the top or the bottom one? Looks like the bottom one, right? And here's 2x minus 3. What is it they look like they substituted for? The y, right?
No, not me.
Huh? Did you just say y?
No, I didn't say nothing.
The y. Well, 2x minus 3, oh no, yeah, 2x minus 3y. 2x minus 3, so he's saying that somehow y equals negative 3x minus 4. Is that true?
Sure.
Well, I don't know.
There's no.
Hey, what does this look like they solved for? In which equation for y? Is this the y? It's supposed to be. So it looks like they did something to the top, right? Y plus 3x equals negative 4. What would you do to solve this for y? What would you do to solve this for y? Subtract 3x from both sides, right? So that gives you y equals what?
Negative.
Or negative 3x what? Minus. Hey, does that look like what they did?
Yeah. Yes.
So is that our correct choice?
Yeah.
Yes. Okay, substitution.
You know.